Welcome to Hasib Electronics. Friends, today we will see thermistor and we will make experiment. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, we are discussing about thermistor. It is also called temperature sensitive resistance. What is its function, how it works, we will discuss in detail in this video. When normal resistance we connect in a circuit, its value remains approximately constant, or it gives a minor change with change in temperature. But thermistor, its resistance decreases rapidly with increase in temperature. When temperature is increased, its internal resistance will decrease. It is made by different metal oxides, and then it is encased in a special packing like this, and it have a special value of resistance. It have a constant temperature constant for calculations according to the type of material. So when the temperature increases, its resistance value will decrease. It have a symbol in this image. These two symbols are American standard symbols. For resistance, it is near to variable resistance, but it have like this. This is Europe and international standard symbol. When we show in diagram, the left image, it is European standard or international standard. This graph, it is temperature to resistance response. We can see the top side, vertical side, it is resistance. The left side or horizontal side, it is temperature. When the temperature is normal, it have its standard resistance, nominal resistance. When the temperature increases, we can see the resistance decreases with the change in temperature. When temperature goes high, the resistance decreases, and when temperature reverse, the resistance return back to its original value. So in any circuit, when we see a black component like this NTC, it is, we can see here, thermistor, it is called temperature sensitive resistance, temperature sensitive resistor or thermal resistor. We can see two types, one is in blue color, one is in black color. The black color, it is thermistor, and blue color, it will varistor. We can check data sheet for any thermistor, any component from internet. We can see 10D9, I have a thermistor. We will keep this thermistor in our practical today. So watch complete video. Here it is complete data for NTC thermistor, NTC 10D9. It is negative temperature coefficient resistor whose resistance changes with ambient temperature change. It is made from different metal oxide. Thermistor comprises 2 to 4 kinds of metal oxides of iron, nickel, cobalt, magnesium and copper. So it can used at a very high range in temperature, very wide range. So in data sheet there are many abbreviations, RT or room temperature. When we see part number, it is NTC, negative temperature coefficient resistance. The first digit 10 will be the value of the resistance for any part component, and the last D9, it is package style and size of the chip. Here parameters are written, type number or part number, and zero power resistance, and room temperature 25 degrees centigrade, maximum steady state current, thermal dissipation, thermal constant and temperature range. It is D7 size. We have D9 size. D9, it is size of the chip. So 10 D9, it is 10 ohm resistance. If we see top in column, and maximum steady current at room temperature, it is 1 ampere. It is in 1 ampere. It is the second one is thermal dissipation. It is constant 11, and the next it is 32 constant. The last one is temperature range. minus 55 degree to 200 degree centigrade. When we go to data sheet, we can find this data in data sheet. Here 11, it is thermal dissipation constant and time constant. When we see resistor, a resistor at left side, the top one, and we see variable resistor, the left side, bottom side. When we see thermistor, we can see like this. We see computer fan. So friends, if you are new to my channel, subscribe, and if you think this video is good, you can make like. And how you find this video, don't forget to comment. Your comment will support me. I will understand my work, and if there is any mistake, any missing, so I will improve in my next videos. Here 10 volt, we see thermistor in series, a fan is connected in series. When low temperature, the resistance of thermistor is high and fan will slow. We see the temperature increases. We will make experiment in the end of video, so watch complete video. Fan speed is slow, temperature high. When temperature is high, the resistance will decrease. When the resistance decrease like this, what will happen? The voltage drop across the thermistor will low and fan speed will high, because fan will take more voltage. Before this, there was a voltage drop across thermistor. Now fan speed is high. So it is used as a temperature sensor also. This is 10D9 as we discussed in our data sheet. It is NTC 10D9 negative. The first digit NTC, it gives us negative temperature coefficient resistance, and the next 10, if here is 5, it will 5 ohm. It is 10 ohm, and the last digit D-9, that is diameter of the chip, size of the thermistor. Is it small? It is big. The diameter of the chip will displayed here. To check a thermistor, we set multimeter to ohm. We check continuity, and we connect multimeter across the resistor. It is giving me 9.1 ohm, because this time it is some hot. I turned on my air condition. When room temperature will reduce, after a while it will come to its normal value 10 ohm. Okay, now I connect test leads. Now it is giving me 9.56. As the temperature is lowering from room temperature, the resistance is going to return back to its nominal value. Now I will turn on heat gun. I will set heat gun at a temperature. I will set temperature from the soldering station, and I will apply heat. Now we can see the multimeter by pressing this button. When I will press this button, there will heat hot air. We can see the resistance value is decreasing. Wow, 4 ohm. Yes, 3, 1. When I remove the heat, and it is returning back to room temperature, we can see the value of the resistance is returning back. Nice. With this experiment, we proved that the value of a thermistor, resistance value of the thermistor will decrease while increase in temperature. When the temperature is decreased, the resistance will increase to its nominal value. Now I have a lighter, cigarette lighter. I wait to return back. Now I will not put a direct heat. I am just making environment hot. We can see it is heat and its value decreased up to 1.8 ohm. Now I will make it cool down. When it is going to normal temperature, its value is returning back. We can see this incandescent lamp. We will connect this lamp with thermistor. I will make soldering in series with thermistor. First we will make tinning to the pins, apply solder, and apply solder to the thermistor, and we will connect these two components in series. Now it is in series connection. Now we will apply 5 volt power, 5 voltage. Now we will connect 5 volt like that. This is thermistor, and here I will make a lamp. Here I am going to give it light. Okay, it is 5 volts. It is a complete circuit. Here I will connect 5 volt. It is in series. In normal condition, it will give its nominal value of resistance 10 ohm. Now I am going to connect a voltage. Yes, I apply heat, and we will see the result. Oh, now it is glowing. Oh yes, it is bright now. I will let it cool down. Now it is cooled down and the light dim again. Now I will apply lighter. It is power on. So friends, if this video satisfies you and you think you want to see more videos, there is a subscribe button. Press subscribe, like, share, and don't forget to write a comment. If this video is good for you, I think I will be more happy that someone can take benefit. We can use this thermistor for different purposes. It is just only a small experiment. We can use this changing value of the resistance in any project. If we have seen an incubator for small babies in hospitals, there are also these thermistors. When the baby cabin temperature reduces, it turns on the heater to make baby comfortable. How we check in the circuit? In our inside PCB, we connect just multimeter like we test our resistance. It should give a value. It is 5D15 sorry, it is 5 ohm thermistor. We can check like this, 6.2 ohm. Yes, it's very simple to test. If there is increased resistance in the thermistor, that means the thermistor is bad. Or if there is short circuit, that means the resistor is bad. Thank you for watching my video.